Okay, so today is our first day for derivatives. Okay, so first thing we got to know is what is a derivative. A derivative, I wrote it on the board, but it's also written up here. A derivative is a slope. That's all it is. It's a slope. Okay, slope is also a rate of change, right? Slope is another way of saying rate of change. Let me write that down. Rate of change. Anything that changes over time, right? That's a slope, right? Miles per hour. When you're driving your car, you see miles per hour. That's a slope, right? If you were to look down, if you were to drive and you were to look down at 1 second when you're on the road and it said 45 miles per hour, that's a derivative at that time, whatever time it was. That's a derivative. It's a rate of change. It's a rate of change because it's a miles over hour per hour, and it's at one time. It's instantaneous. So you just look at it over one. You just look down at it, whatever time it was, that was your slope, or that was your derivative. Okay. So a derivative is a function. So we have two things. We have a derivative function or derivative equation. We use that to find the slope of a tangent line at a certain x value. Okay, so slope we're pretty good with. You guys have seen that word slope since probably junior high. Rise over run, y2 minus y1 over x2 minus x1, that kind of thing, right? Tangent line. So a tangent, when I'm talking about a tangent, I'm not talking about like trig. I'm not talking about like sine, cosine, tangent. I'm talking about something that is tangent to something. So something that is tangent, I'll give you an example. So let's say this is my graph. The red one is the graph. A tangent line would look something like this. I'll draw it in blue. So the blue line is tangent to the red. We'll call the red f of x. At point A. So what does the blue line look like it's doing to the red, to f of x at A? What is it doing? It's barely touching it. In fact, it touches it at one spot. It touches it at one spot right there. It kind of ricochets off of it, right? It hits it. The blue line is only hitting f of x at one spot. One spot. Okay? That's a tangent. And it only hits it at one spot. So in other words, if I keep doing whatever it is I'm doing at A, that's where it would happen. So if it was speed, miles per hour, if I were to keep going that speed forever and ever and ever, it would follow the blue. But I change speeds, right? When you're in a car, you change speeds. You slow down, you speed up, you stop at a red light, stop at stop signs, right? So that's why it changes. But if I were to keep doing what I was doing, that's what a tangent line is. Okay? If I were to keep doing exactly, if my rate of change would never change at that point, that's called a tangent line. Okay? But like I said, that's not how it works, right? Because when you're in your car, you speed up, you slow down, you speed up, you slow down. You know, even when you're on the highway, you're going faster, but sometimes you have to slow down for traffic or whatever. So that's what the tangent line is. A tangent line. So what a derivative does, a derivative is the slope of a tangent line at a certain x value. Okay? So when you hear the word derivative, there are two things that should go through your head. First thing is slope. Slope. Slope of what? A tangent line. A tangent line, right? That's what a derivative is. So you're going to be hearing derivative for the rest of the year. So when you hear a derivative, you want to think slope, slope, slope. That's the first thing. It's a slope. It's a rate of change, right? Of what? A tangent line. Okay. So that's what we're doing. That's what a derivative is. Okay, the derivative f prime of x is a function which gives the slope of the tangent line to the curve f of x. A derivative equation or a derivative function, or sometimes called a differential equation, is the thing that allows us to find. It's the tool we use to find the derivative. Okay. So before we start getting into some how to find it, first thing is first. Let's skip ahead a little bit. You're going to see a lot of symbols that you've probably never seen. Unless you've been in calculus or done some calculus, you've probably never seen these symbols. They're symbols for derivative or differentiate. Okay, so the first one, the F with a little it looks like a little apostrophe, it's called F prime. So anytime you see F with a little tick mark, that means the derivative. That's the derivative equation. Okay? Sometimes you'll see d over dx of f of x. That means the derivative of f of x with respect to x, with respect to x of f of x. D over dx means it's an action verb. So when you see this guy here, it's an action. It's a verb. It means do it. Find the derivative. D over dx means find the derivative. That's what you need to do. F prime and y prime means it's already been done. Here's the answer. Here's the derivative or derivative equation. Okay. Same thing with the last one. dy over dx. dy over dx is the derivative. So these guys here that I'm going to highlight in blue, these all say the same thing. This is the derivative. They're saying this is the derivative. So most of the time you'll see this equals, this equals, this equals, because that's the derivative equation. Okay. D over dx means to differentiate. What does differentiate mean? It's the verb. Find a derivative. So if you see it says differentiate, it means find the derivative. They want you to do something. Derivative on its own is just a noun, right? Okay. So there's lots of different ways to find the derivative. Today I'm going to show you the definition. It's called the definition of a derivative. Okay? So we're going to be finding derivative equations today. And then as the chapter goes, I'll show you different ways to find the derivative. Okay? But just symbols and words you're going to see. The reason why they have so many symbols for one thing, the derivative, is because it kind of goes back to the history of calculus. The history of calculus was invented by two different people. The first person who gets most of the credit is Isaac Newton. Sir Isaac Newton, the guy who the apple fell from the tree and hit him on the head and he discovered gravity, right? He's the one who gets... Thanks, Leon. Yeah, I'm good, though. Yeah, I'm good. Thank you. He's the guy who gets the credit. Like, if you were to look it up and say, who is the father of calculus, it would probably be Isaac Newton, right? But at the same time, so he was in England. Sir Isaac Newton was in England doing his thing. He was coming up with calculus. He was looking up derivatives, slopes, all that stuff. At the same time in Germany was this other guy with the last name of Leibniz. I forgot his first name, but his last name was Leibniz. He was in Germany at the same time. Now, this is back in the 1700s. There was no TV. There was no internet. There was no radio. There was nothing technology-wise. So somebody from England and somebody from Germany, even though it's not that far away, they would never meet. There's no way to communicate. The only way to communicate is by sending letters, and they didn't even know each other. They didn't have any friends that were... There was nothing Nothing, no way for them to communicate with each other. So Isaac Newton was in England, Leibniz was in Germany. They were doing the same exact stuff. They were inventing the same exact stuff, which was what we call calculus. So when we say who's the father of calculus, it's two people. It's Newton and Leibniz. So the reason why we use all of these different notations is because Newton liked f prime, liked y prime. I like those. Leibniz liked dy over dx, d over dx. He liked that. So one is Newton notation and one is Leibniz notation. That's the difference. That's why we have so many different things. Why can't we just have one? Well, because there were two people inventing the same thing at the same time. They were literally doing the same thing, the same work at the same time. Had no idea they were doing it, but that's why. Okay, it's kind of interesting with calculus that happened. That they were doing the same thing. They made the same discoveries in calculus, same discoveries in limits, derivatives, integration that each other was doing just a few countries away. Okay. Okay, so here we go. Remember, the derivative equation or the derivative function is a tool to help us find the slope of a function at a specific point. Okay, so what we're going to do is find the derivative equation. We're going to find it using f. So it says find f prime. Here is the equation right here. F of x equals x squared. That's what we're going to find the derivative. I'm going to find the derivative of x squared. I'm going to use what's called the derivative definition. What is the definition? It's right up here. We skipped it earlier, but I'm going to come back to it. It's this guy right here. It's a limit. It's a limit. This is the reason I start with this one, is because you guys just did a whole chapter on limits. So this kind of makes sense to you. Without the f prime, right? Okay. So what this says is f of x plus h minus f of x over h. The limit as x approaches 0. So let's go. So I'm going to plug that in over here. Okay, so f prime of x, because that's what I'm doing, I'm finding f prime, equals the limit as x approaches 0. Oops, not x, h. Okay, let's go back up here. This part right here, f of x, we know f of x. What is f of x for this guy? It's x squared, right? It's equal to x squared. So we know that part. So let's start with that part. All right, so let's put that there. H is by itself at 0. H is by itself, sorry, at the bottom. Okay, so let's put it. The part that can be confusing to some students is this part right here. This part right here. Right? We know what f of x is. It's the function, x squared. H is this h. Right? So what do we do for the yellow? Well, think of this. If I were to say f of 1, what does that mean to do? So how do I find that? So how do I find that? You're right. The answer will be the y value, right? But how do I solve this? What do I need to do? Plug in 1 into the equation where? Where would I plug it in? Anywhere there's an x. Anywhere there's an x, right? Doesn't matter what it is. Doesn't matter if it's 2a. Doesn't matter if it's anything, right? Anything in here, I'm going to plug in anywhere I see an x, right? Okay. Well, what am I going to plug in here? In the yellow. Okay, let's go back one more time. Let me give you an f of x. F of x equals 2x plus 4. I don't want the answer. I just want to know how. How do I solve this? So plug in 1 everywhere I see an x value. There, there. Same thing here, right? Same thing here, everywhere. Okay. So let's go back to the yellow. How do I do that yellow part? So I'd plug in whatever is inside the parentheses. Anywhere there's an x, right? So let's go back to our thing. Where is there an x? There's only one, right? There's for x, the squared part, right? So that's what I'm going to do. I'm going to go plug in x plus h squared. Because the only place I could plug it in is there. That's the only place I could plug it in. Okay. Okay, so now that I got all that, how do I solve this limit? We just took a test last week, right? How do we solve this now? What do we need to do? Plug in 0 everywhere I see an h, right? Everywhere I see an h, I got to plug in 0. So let's do that. X plus 0 squared minus x squared over 0. Okay. So x plus 0 is just x. So x squared minus x squared over 0. X squared minus x squared, 0 over 0. So what happened last chapter? When we got that? We had to do something, right? We're not done yet, right? We're not done yet. There is a limit, but I have to keep doing some work. Okay, so let's look at this guy here. Let's look at this guy right here. What work could I do? What work could I do? I could do the conjugate, but before I did that, what else could I do? Not factor, you're close, the opposite of factor. Multiply this, multiply it out, right? See what I would get, multiply it out. It's a binomial, squared. So what I'm going to do is that's what I'm going to do. I'm going to go do this over here. So I'm going to take this guy over here. It's x squared, x plus h squared. So it's a binomial times a binomial, right? That's what that means. Okay. So we use FOIL. First, outer, inner, last. So we get x squared plus x times h plus another x times h plus h squared. That's what it multiplies out to. Okay, I'm going to go put that back. The limit as h approaches 0 So it was x squared plus, aren't these guys like terms? So we can combine them together. So how many do I have? I have one there, I have one there, I have two of them. 2xh. They combine to make 2xh. Okay. Plus, sorry, not x squared, h squared. Okay. That's what the parentheses were there for, all right? So let me draw another arrow back. Okay. Well, I still had a minus x squared, and I still have a h. All I did was multiply. That's all I did. So what can I do now? The x squareds are going to cancel out, right? Because there's a positive one and a negative one. So let me try plugging in 0 now. Plug in 0 everywhere there's an h. So on top, it's 2x times 0 plus 0 squared over 0. Well, 2x times 0 is just 0. 0 squared is 0. I still get 0 over 0. There's still work to be done. What could I do now? Which part is causing this? Which part is causing me to say this not? Which part is causing this not for me not to be finished? The bottom. The denominator is causing me. If I got anything other than 0 on the bottom, I would be done. 0 on top is okay. That's just 0. 0 on bottom is the one that's causing me the issue. So I'm trying to find a way how to get rid of that bottom. So let me rewrite what I have. Two xh plus h squared on top. Bottom, I just have a regular h. I know if I plug in 0 for h, I'm just going to get 0 over 0. I tried it. But what could I do? What else could I do? Starts with an F. Factor. What could I factor out? Yeah, don't all three terms have an h? We could factor out an h. So I can rewrite it as the limit as h approaches 0, factor out an h. That would leave a 2x plus h over h. Cancel out an h. So that leaves me with the limit as h approaches 0. Now I don't even have a denominator. It's just 1. 2x plus h. Plug in 0 for h. What do I get? 2x. So f prime of x is equal to 2x. That's the derivative equation. It's called a differential equation. It's the derivative equation. If I wanted to know the slope at a point, I would plug it in. If I wanted to know the slope at 1, I would plug in 1 for x. If I wanted to know the slope at 3, I'd plug in 3 for x, right? So this is not the slope. It's what we call the derivative equation. It's the tool that'll help me find the derivative. They didn't ask me to plug in any numbers. They just said find the derivative, find f of x, find f prime of x. So I'm done for this one. I am done. The derivative of x squared is 2x. Okay. All right. Okay, so now let's look at example number 2. We're going to do the same exact thing. This one's a little different though, because not only do they want us to find f prime, but then they want you to go a step further and find the slope of the tangent line at x equals 5. Okay? Okay, so let's set up our limit. So f prime of x is the limit as h approaches 0. H goes on bottom always. F of x goes second, right? I'm subtracting the whole thing. So that's why I put parentheses, because that's f of x. All right, let me write it over here. Okay. H is just h. F of x is just the equation, right? How do I find f of x plus h? I plug in x plus h everywhere I see an x. Where do I see an x? I see it there. I see it here, here, and here. Everywhere I see an x, I'm going to plug in an x plus h. How is that going to look? It's going to look like this. Negative 2 x plus h squared. Minus 7 x plus h. Plus 7, because 7 doesn't have an x. The last 7, that positive 7, doesn't have an x. So this one was a trinomial. The one we just did was a monomial. It had one part. So this one's got more parts to it. So that's why there's more x plus h's. Everywhere there was an x, I plug in an x plus h. So if I were to plug in 0 for x, I would get negative 2 times 0, or negative 2, I would get negative 2x squared minus 7x plus 7 minus the same thing, right? So would I have 0 on top and 0 on bottom again? Because if I plugged in 0 to find the limit, if I plugged in 0 there, it would just be negative 2x squared minus 7x plus 7. Isn't that the same thing as this? And I'm subtracting them, so they would just go away, right? So that means I would be left with 0 on top. And then if I plugged in 0 on bottom, I would have a 0 on bottom. So we got to think of other ways. Well, this is a trinomial. We just did a monomial. They're kind of similar. They're both polynomials. What can we do here? Expand it, right? Let's do what we did last time. The nice thing is, I did this part already, right? This part right here. Didn't I already do? So I already know the answer, right? So I don't have to multiply again. I already know the answer. -2 times, when I multiplied that guy, I got x squared plus 2xh plus h squared, right? That's what I got. And then I can do distributive property here. -7x minus 7h plus 7. And then I can do distributive property here, here, and here. Plus 2x squared plus 7x minus 7. Just for the record, none of this is calculus. Distributing, multiplying, that's not calculus, that's algebra. Okay? That is the hardest part about this, is not the calculus part. The calculus part says, oh, plug in 0. Well, that didn't work. So then we got to go back to algebra and use that. Okay? So I still have a distributive property to do. So I get -2x squared minus 4xh minus 2h squared. And then I have my long So a lot of people look at that and they say, I hate calculus. It's not calculus. It's algebra. It's math 1 stuff. You guys did this in math 1 and math 2, especially math 2. Okay? Which is another reason why I do the summer assignment, because you have to be able to distribute. You have to be able to multiply. You have to be able to do that stuff to do the calculus. Okay? So now let's see. I got a lot of things that will cancel out. That guy and that guy go away. I have a positive 7x and a negative 7x. Those guys go away. Those guys go away. I have a positive 7 and a negative 7 that go away. So pretty much the only things that stay on top are the things with h's. The things with h's. So on top, I have a negative 4xh minus 2h squared minus 7h over h. Okay. So if I plug in 0 now, I'd still get 0 over 0, because 0 would multiply here to make 0, to make 0. I'd still get 0 over 0. But what can I do? What did I do last time that would help this time? Factor, right? They all have h's. H's here, 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 here. They all have h's. So I can factor out an h. So the limit as h approaches 0, factor out an h. This guy still, he has an h left. This guy loses the h. So now I have the limit as h approaches 0 for negative 4x minus 2h minus 7. Now when I plug in 0, I get negative 4x minus 2 times 0 minus 7. That leaves negative 4x minus 7. That is the derivative equation. That's not all they were asking for, though. Let's go back to the question. The question said, I want you to use it to find the actual slope at x equals 5. So what we have to do is use that. I'm going to use that. So let me move back over here. Negative 4x minus 7. Yep. So they want to know the slope at 5 when x equals 5. So everywhere you see a 5, everywhere you see an x, you're going to plug in a 5. Negative 20 minus 7 equals negative 27. And you are done. Okay. Derivative is a word you've never heard before unless you've taken a calculus class, right? Derivative is not a word we use in Math 1, Math 2, Math 3. Same thing with limits, right? Limits, maybe some pre-calculus classes, you'll hear it if they get to that, right? But have you heard the words factor? Have you heard the words multiply? Have you heard the words expand? Have you heard the words like terms, plug in, right? Those are all words you've heard probably since junior high. That's the hard part about this. That's the hard part. Derivatives aren't hard. They're not hard. But it's all the other stuff, right? The factoring, this stuff here. A lot of people look at this and they're like, oh, that's a lot of work. Yeah, but it's not calculus. What did we do up here? Multiply. You've heard multiply since the 3rd grade, right? Distribute. You've heard distribute probably since the 7th grade. Distribute. Combine like terms, probably since middle school, right? Plug in zero, factor, right? Those are all words you've heard before. Now, it's tedious because there's a lot of parts, right? There's a lot of parts to it. But what my point is that the calculus isn't that bad. And starting on Wednesday, we're going to have the same exact question here. I'm going to give you the same exact question. And we're going to do the same exact thing. But I'm going to start teaching you the rules for differentiation. And the rules are a lot easier. This problem on Wednesday would take us probably 15 seconds to do. Today, it's taken us 5 to 10 minutes, right? The reason I start with the definition is because you know what a limit is, and because they always ask about the definition. Okay? There's always a question or two on the multiple choice part that ask about the definition. And if you've never seen this before, you're going to be like, what? Right? But if you have seen it before, it's not so bad. Okay? So that's why I always start with the hard part first, the long way first. Don't worry, we're not going to keep doing this forever. This is the only day we will do this, the long version. Starting Wednesday, we'll do it the short way. Okay? There's a shorter way to do it, trust me. Like I said, on Wednesday, you'll do this problem and it'll take you about 15 seconds max. Okay? But today, like I said, I want to do it the long way because once I show you the short way, you're not going to want to go back. Okay, so don't worry. Is this all we're going to do for every single? No. This is just for today. Okay? All right, so number 3. We got to find the equation of the slope of the tangent line at x equals 1. Okay, so that's derivative. They want us to find the derivative and then use it to find the slope at 1. Okay, so let's look at our derivative, our definition here. H goes on the bottom. F of x goes over here, right? What do we write in the blank? So what is it going to be here? Yeah, tell me what are we going to write here? Yep, you plug in x plus h everywhere you see an x. Well, the only place I see an x is right there. So it would be 1 over x plus h. Give yourself a little room here. Plug in 0, right? Plug in 0 for h. I'm going to get 1 over x minus 1 over x, that's 0, over 0. Okay. This one should look very, very familiar because you've seen stuff like this last week on your test. There was 1 or 2 questions. Was there a question? Maybe on your group test or individual test, a multiple choice problem like this, where you had to find a limit like something like this. What did you do when you had to find the limit for something like this? You have to you do the top, right? You found the common denominator of the top, right? So let's focus on the top first. I'm going to kind of cut this part out and then bring it back. So we get 1 over x plus h minus 1 over x, right? This is the last one we'll do. Then number 4 we'll do tomorrow, and I'll give you some time to work on the assignment tomorrow. Common denominator, something you had on your summer assignment and summer assignment quiz, right? So we have a binomial here. We have a monomial here. So this guy needs a binomial. This guy needs a monomial. So the common denominator is x plus h. So I get 1x, and then I got to distribute -1 here and here, minus x minus h. The x's go away because they cancel out, so I'm left with -h over x plus h. Let me move that back to where I started. That's just a summer assignment thing. So if I gave it to you for your summer assignment, it wasn't calculus, because I hadn't taught you calculus yet. Okay. So I'm going to move that. So I'm going to rewrite this. Instead of the top being that, it is -h over x plus h. Okay. Still get 0 over 0 if I plug in 0. But what do we do after this? Yep, we can rewrite it. This is just a division problem. Negative h x plus h divided by the bottom, which is just h. How do we divide? Keep, change, flip. The h's will factor out to become 1's. And you get negative 1 over x plus h. Plug in 0 now. What do we get when we plug in 0 for h? I get negative 1 x times x, which is negative 1 over x squared. That's the derivative equation. For 1 over x. The derivative of 1 over x is negative 1 over x squared. Okay, the last thing I have to do is find the derivative at 1. So negative 1 over 1 squared equals negative 1. The slope is negative 1. Okay. All right. The last one here we'll do tomorrow. So tomorrow what I'm going to do is we're going to finish that. It'll take us 10 minutes, if that. And then I'll let you work on the assignment. I'll give you some practice problems to do. Okay? The rest of the period. And then Wednesday, I'll show you how to do these. I'll give you some rules, whether it's called rules for differentiation, which will make this a lot easier. These problems will become a lot shorter once we do that. Okay? Mm-hmm.